So now we're back just to look at a new type of form, and this one is called the vertex form. So vertex form looks like this. Y equals ax minus h squared plus k. And we're going to talk about what these different values are. The reason this is called vertex form is because it's an equation that you can actually will end up getting to the point where you can look at it and you can actually tell what the vertex is of this quadratic. So it actually makes it a little bit easier to graph, or at least to start the graph. So as you know, the vertex is the max or minimum of a parabola. So I'm just gonna, oops, I'm getting a new color here. Just going to draw a really quick sketch of a parabola. So our vertex in this case is down here. This is our minimum point. So this is our vertex. EX, there we go, spelling. And we are going to, wow, that was bad. Let's back it up for a second. So I'm gonna attempt to do a straight line. And it could look something like this. This is another parabola as well, and the vertex is here, and now that one is at a maximum. So this is our vertex as well. Just that max or minimum. My pen's fighting with me here. Of our quadratic. So depending on if the quadratic opens upwards or downwards. So when it opens upwards, we have a minimum value on our vertex. And when it is opening downwards, we have a maximum value associated with our vertex. So what we're going to actually do is we're going to analyze this value here and basically use a graphing program to tell us if we change that value, what happens to our parabola, like what happens to the way it looks. So we're going to do that in a second. All right, so here I am on the Desmos website, and for those of you that don't know it, it's DESMOS. They also have a pretty good app, so you can download that on your mobile devices. So what we're going to look at is, we're just going to look at the most basic parabola, which is y equals x to the power of 2, and this is what the most basic parabola looks like. So what we're going to do now is I'm just going to put in another equation, and we're going to analyze just that first letter, that A that pops up there. So in this top one, it's actually a 1 that's sitting there, so you can see the graph didn't change when I included a 1 there, so we don't really need that. So what I'm going to do is I'm going to make the number larger. So let's say I say y equals 2x to the power of 2. So you can see, so that's my blue one, it's gotten a lot more narrow. So it's kind of like I've taken my my red graph there, my y equals x squared, and I've actually kind of stretched it along the y-axis, like I've kind of pulled it tighter. So the blue, which has that larger a value of a 2, is actually more narrow, so it's more stretched along the vertical or along the y-axis here. And what we call this is we call this a vertical stretch by whatever factor is right here. So I'm going to do another one just to show you that it continues that way. So I'm going to do y equals 3x to the power of 2. We're going to see that, yes, in fact, it's still continuing to get more and more stretched. So you can think of it as I'm pulling it more tightly. You can also think of it as the values are getting larger at a faster pace. Just to conclude that, I've been changing the A. So this is again my vertex form. Oops, it should be A minus, oops, minus, I don't know where my eraser is. Oh, there it is. Oh dear. Y equals A x minus h squared plus k, so that's my vertex form. And we're again just looking at the A here. So where this value here is increasing, so when A is bigger than 1, we're finding that the parabola is actually getting vertically stretched by a factor of whatever's there. So a factor of A, we'll call it in this case, because it can vary. So when A is larger, and again that symbol means it's larger because it's open to the larger value. So when A is larger, is greater than 1, this is called a vertical stretch. Vertical stretch. And it is written as by a factor of A. And so whatever the value is, we pop it in there. So in the case of this one here, we would say that this is a vertical stretch by a factor of 3.